Learn Python with me, smiley face. A guide by Anas Khalid. Terminologies of Python. 1. Introduction to Python 2. Variables and data types 3. Control flow and loops 4. Functions and modules 5. Object-oriented programming 6. Exception handling 7. File handling 8. Regular expressions 9. Libraries and frameworks. 1. Variables and data types. In programming, a variable is a container that holds a value or a reference to a value. Data types, on the other hand, define the type of value that a variable can hold. In Python, there are several built-in data types, including numeric types, integers, floating point numbers, and complex numbers. Boolean type, true or false. Sequence types, strings, lists, and tuples. Dictionary type, a collection of key-value pairs. Set types, an unordered collection of unique elements. Control flow and loops. Control flow refers to the order in which statements are executed in a program. In Python, control flow statements allow you to control the execution of code based on certain conditions or events. The most common control flow statements in Python are 1. Conditional statements. If, elif, and else statements are used to execute different blocks of code depending on whether a certain condition is true or false. 2. Loop statements. For and while loops are used to repeat a block of code multiple times, either a fixed number of times or until a certain condition is met. 3. Break and continue statements. These statements are used to modify the behavior of loops. The break statement is used to exit a loop prematurely, while the continue statement is used to skip to the next iteration of a loop. Loops are a type of control flow statement that allows you to execute a block of code multiple times. There are two types of loops in Python: for and while loops. 1. For loop. A for loop is used to iterate over a sequence of values, such as a list or a string. The loop will execute once for each value in the sequence. 2. While loop. A while loop is used to execute a block of code repeatedly as long as a certain condition is true. The loop will continue to execute until the condition becomes false. Loops are a powerful tool for automating repetitive tasks and processing large amounts of data in Python. Functions and modules. Functions in Python are blocks of reusable code that perform a specific task. They can take input and return output, and help make code more organized and easier to read. Modules are files containing code that can be reused in other programs, and can include functions, classes, and variables. Python has many built-in modules and third-party modules that can be used to perform a wide range of tasks. By using functions and modules, you can write more efficient and scalable code and reduce redundancy. Object-oriented programming. Object-oriented programming, OOP, is a programming paradigm that focuses on the use of objects to represent and manipulate data. An object is an instance of a class, which is a blueprint for creating objects with a defined set of attributes and methods. In OOP, objects have attributes that describe their state, and methods that define their behavior. For example, a car object might have attributes like color, make, and model, and methods like start, accelerate, and brake. The 4 pillars of OOP are 1. Encapsulation. Encapsulation is the practice of keeping the data and methods that operate on that data together within a class, to prevent unwanted access or modification from outside the class. 2. Inheritance. Inheritance allows a new class to be based on an existing class, inheriting its attributes and methods. This allows you to reuse code and create a hierarchy of classes with increasing levels of specialization. 3. A polymorphism. Polymorphism allows objects to take on different forms, depending on the context in which they are used. This allows you to write code that can work with different types of objects, as long as they share certain methods or attributes. 4. Abstraction. Abstraction is the practice of focusing on the essential features of an object or system, while ignoring or hiding the irrelevant details. This helps to simplify complex systems and make them easier to understand and use. OOP is a powerful paradigm that is widely used in modern programming languages, including Python. By using OOP, you can write more modular, reusable, and scalable code and create complex systems that are easier to manage and maintain.